viewers, this is Kasturi Day. Today I'm going to discuss or rather start with the atomic structure chemical bonding question answers, the back questions generally, and some other some other questions will also be there for your so that you can perform well in the exams, okay, and that will help you in understanding the chapter. So with that, we'll start today's discussion. And before we start, I will ask you to please subscribe my channel. And if you have not subscribed yet, and if you have subscribed yet, then please ring the notification bell because that will help you to get the notification as soon as a new video is uploaded. Okay, and also if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos, and also do meditate before you start your day. So we will start with the meditation of the day, and then we will start with the discussion. Okay, so for meditation, let us concentrate on a point of light. Okay. That the rays of light from that small point is reaching you. The whole body of yours is lighting up. You're getting energy from the light. You are so energetic now that you can perform the whole day enthusiastically, with interest and with love. Each and every work you do that will give you happiness, and you will become successful at the end of the day. And we thank God for giving you such energy, for making you successful at the end of the day, and for making you happy. So increase your concentration, increase your willpower, enthusiasm, interest in studies. So, first question of the day is, what is the contribution of the following in atomic structure? Maharshi Kannada and Democritus. Maharshi Kannada gave the idea of the smallest unit of matter. According to him, matter consisted of indestructible minute particles called paramanus, which are now called as atoms. He also gave the concept of the molecule. So Maharshi Kannada, he was the first one to tell that the idea that there's the smallest unit of matter. Okay, he gave the idea of the smallest unit of matter. Okay, and he told that the matter consisted of indestructible particles, which he named as paramanus, but now it is called as atoms. He also gave the concept of the molecule. Okay. Now, Democritus called the paramanus as atoms. I told you that in Maharshi Kannada, the paramanus, which was named by Maharshi Kannada, they were known as later on as atoms. When this atoms was named as, these paramanus were named as atoms by Democritus, okay, which is derived from the Greek word atomos, which means indivisible, which cannot be divided, okay. Now the next question is, state Dalton's atomic theory. According to Dalton's atomic theory, there are certain postulates which we follow, okay. So these postulates are: matter consists of very small and indivisible particles called atoms. Atoms can neither be created nor be destroyed, but they differ from the atoms of another elements. other elements, then atoms of an element combine in small numbers to form molecules. Atoms of one element combine with atoms of another element in a simple ratio to form the molecules of the compounds. Atoms are the smallest units of matter which can take part in the chemical reaction. So six postulates, so 6 points are there in the postulates. Okay, so first one is matter, so which consisted of it consists of very small and indivisible particles. Okay, which very small particles, very minute particles, which cannot be divided, and these particles are known as atoms. Okay, then atoms. These atoms can neither be created nor it can be destroyed, according to this postulate. Okay, then the atoms of an element are alike in all respect. Of a single element, all the atoms are same, but they will differ from the atoms of other elements. Okay, then for example, see, if we consider oxygen and carbon, so the atoms of oxygen will be similar, and one atom will be similar to the other atom of the same element, that is oxygen, but one atom of oxygen will differ from the one atom of carbon. Okay, so this is the meaning of this point in the postulate. Then atoms of an element combine in small numbers to form molecules. Okay, atoms of an element, they combine in small numbers in the form to form a molecule. Then atoms of one element combine with atoms of atoms of another element in a simple ratio. Okay, they fourth point is they will combine in small numbers. Okay, and the fifth point is they will combine with one atom of another element. In the fourth point, combining in the same element, and fifth point is combining with the atom of another element in simple ratio to form the molecules of the compound. Okay, then atoms are the smallest unit of matter which can take part in the chemical reaction. Okay, atoms are the smallest unit of the matter which can take part in the chemical reaction. Now, third question is, what is an alpha particle? It is the positively charged particle. Alpha particle is positively charged particle consisting of 2 protons and 2 neutrons. Okay, so these are positively charged particles consisting of 2 protons and 2 neutrons, which are bound together, but emitted by an atomic nucleus undergoing radioactive decay and is identical to the nucleus of a helium atom. So it is, this alpha particle is very similar to the helium atom, nucleus of the helium atom, consisting of 2 protons and 2 neutrons, and they emit, these alpha particles are emitted when an atomic nucleus is radioactively, it is decayed. Okay, when an atomic nucleus radioactively decays, then it emits these alpha particles. Okay, and this consists of 2 protons and 2 neutrons, and this is very much similar to that of the nucleus of the helium atom. So this is alpha particle. Okay, next is, what are cathode rays and how are these rays formed? Cathode rays are the beam of electrons which travel from the negatively charged part end, that is the cathode end, to anode end of a vacuum tube across a voltage difference between the electrodes placed at each end. Okay. So we take let us take a vacuum tube in which there are 2 electrodes. One is the negative, another is the positive. Negative one is known as cathode, and the positive one is known as anode. So the beam of electrons which is being discharged from the negatively charged end, that is from the cathode, it's moving towards the positive end, that is the anode end. Okay. So this is cathode rays. So these beam of electrons is forming the cathode rays. The formation. Generally, gases are poor conductors of electricity. So gases are generally poor conductors of electricity, but how are they formed, that is formation? So gases are generally poor conductors of electricity, but when a high voltage charge or high voltage current is passed from an induction coil is applied to the tubes filled with gases at very low pressure. Pressure should be 0.01 millimeter of mercury. Okay, and the gases become good conductors of electricity and they begin flow in the form of rays and begin to flow in the form of rays. And these are the cathode rays which travel from cathode towards the anode. So what happens? How are they formed? See, to form this cathode rays, we should take a gas. Generally, gases are poor conductors of electricity. But when gases are taken inside a cathode, a tube, vacuum tube, and in that tube there should be very low pressure. Okay, the pressure should be very low. How much? It should be 0.01 millimeter of mercury or Hg, you can say 0.01 millimeter of Hg or 0.01 millimeter of mercury. Okay, so that much pressure should be there inside the cathode tube, and inside this tube, vacuum tube, and through this tube, the high voltage charge should be passed. Okay, then what happens when this high voltage charge is passed inside the this tube, and there is a very low pressure, and then the gases ionize. Okay, and they form good conductors of electricity. Okay, so and begin to flow in the form of rays, and then they start forming the rays. They move from cathode to the anode, and these rays are known as cathode rays. Clear? So from the picture we can see that's how the cathode rays are produced. So this is the vacuum tube here, in which there is a very low pressure, and these are the two electrodes, that is cathode and anode electrode, which are being connected by an electric charge and which is conducting a very high voltage. Okay, so when this very high voltage is passed through, then the cathode will emit certain rays which will move from the cathode to the anode. Okay, and this will form a greenish glow inside on the side of the anode. So this is the diagram which shows the production of cathode rays. Now, what is the nature of the charge on cathode rays and anode rays? So cathode rays will have negative charge because it's emitting from the cathode, which is negative electrode, and anode rays are positively charged because anode rays are emitted from anode, which is a positive electrode. Okay. Now, how are X-rays produced? X-rays are produced when high energetic electron beam is made incident on a metallic target of high melting point and high atomic weight. So how are they produced? Let us take a metallic target, which has a very high melting point, metal, which is having a high melting point, very high melting point and high atomic weight. That type of metal should be taken, and on which the high energetic electron beam is incident. Okay, let the high energetic electron beam fall on this metal target. That will produce the X-rays. Okay, that will produce the X-rays. So two conditions are needed. One is metal, which is of high melting point and which have high atomic weight. That type of metal should be there, which is a target. Then another thing is required, that is electron beam, which should be highly energetic. So highly energetic electron beam should fall on this metal target, which would produce the X-rays. Now, why were anode rays called as canal rays? Why were they called canal rays? In the discharge tube, that is the vacuum tube which we use to produce the cathode rays or the anode rays. So that rays is known, that tube is known as discharge tube. So in the discharge tube experiment, set of rays that travel in a direction opposite to the cathode rays are found. So in the discharge tube, some rays are found which will move opposite to the cathode rays. These rays are known as canal rays. Why they are known as canal rays? Because they pass from the hole through the holes of the canals. Because in the experiment there are certain canal used, and through this rays pass through the holes, the canals, these rays pass through, and that's why these rays are. Now, how do cathode rays differ from anode rays? The difference between cathode rays and anode rays. Cathode rays travel from cathode to anode, and anode rays from anode to cathode. Okay, it's very simple. Then they are made of negatively charged particles. Cathode rays are made up of negatively charged. Anode is positively charged. Okay. Now these cathode rays produce a greenish yellow fluorescence on the soda glass screen. If there is a soda glass screen and cathode rays are made to fall on it, then it will form a greenish yellow fluorescence. Okay, and for anode, they will produce a fluorescence on the zinc sulfide screen. If anode rays are made to fall on the zinc sulfide screen, they will form a fluorescence. Then cathode rays are affected by an electric field. That means they are inflected towards a positive field and deflected towards deflected away from the negative field. Not towards, deflected away from the negative. As cathode rays are negatively charged particles, so they will be affected by the electric field. How? By getting inflected towards a positive field and getting deflected away from a negative field. Okay, because similar charge will deflect. Okay, and its opposite charge will inflect. And in case of anode rays, they are deflected by electric and magnetic fields both, but in a direction opposite to that of the cathode. That is, they will be inflected towards a negative field and deflected towards, deflected away from the positive, because it is a positively charged particle, positively charged rays. In state one observation which shows that atom is not indivisible, which will show. So Chadwick discovered neutral particles which are present in an atom by bombarding light nuclei like beryllium with alpha particles. This is known as helium nuclei. Alpha particles also known as helium nuclei. So by bombarding beryllium with this helium nuclei or the alpha particles, what did Chadwick discover? They produce some neutral particles present in an atom. These are known as what? These are known as neutron, by which neutron was discovered. Okay. And so we can say that it is not indivisible means it is divisible. Okay. So discovery of neutron showed that atoms are divisible. Or you can say atoms are not indivisible. Okay, from the experiment of nuclei. From the experiment of neutron. Okay, how from the experiment that neutron has been discovered, from that experiment, one can say that one can observe that atoms are not indivisible. Here, next we move on to the next question. That is, name an element which does not contain neutron. If an atom contains one electron and one proton, will it carry any charge on it? So the first one, name an element which does not contain a neutron, that's hydrogen. It contains only one proton and one electron, no neutron. And protons are positively charged, whereas electrons are negatively charged. So if one element contains one proton and one electron, then their charges will be balanced. Therefore, there will be no charge, neutral charge. Now, on the basis of Thomson's model of an atom, explain how an atom as a whole is neutral. As per Thomson, the model of atom is similar to that of the plum pudding. According to Thomson, he gave an he did an experiment. He took a plum pudding in which there was a spherical shape where fruits, dry fruits, are embedded into it throughout the pudding. They're spread throughout the pudding. Now, similarly, an atom has negatively charged electrons which are embedded in a positively charged sphere. We told that the atom is a sphere of positive charge, and there will be the electrons which were negatively charged that will be embedded in this positive charge, like that of the plum pudding, where there were fruits which were embedded in the pudding throughout the pudding. Now, he explained that the total positive charge is equal to the total negative charge contributed by the electrons embedded. So the negative charge which were embedded in the the negative charged electrons which were embedded in the positively charged sphere, that equaled the charge of the total number of negative charge that equal to the number of positive charge, which was the charge of the sphere. So that's why the atom is neutral as a whole. So the charges are balanced. So therefore, the atom will contain a neutral charge. Now, which subatomic particle was discovered by Thomson, Goldstone, and Chadwick? Thomson discovered electron, Goldstone discovered proton, and Chadwick discovered neutron. Name the subatomic particle whose charge is +1, -1, and 0. So +1 is proton, -1 is electron, and 0 is neutron because it doesn't have any charge. Now, which metal did Rutherford select for his alpha particle scattering experiment, and why? What do you think would be the observation of alpha particle scattering experiment if carried out on heavy metals like platinum and light nuclei like lithium? So for his alpha particle experiment, scattering experiment, Rutherford selected a thin sheet of gold metal. So what metal did he select? He selected gold metal. Okay? And it was a thin sheet of gold metal. So why did he select so? It is so because in this experiment, he wanted such a metal which could be made very thin, as thin as possible. That is, it should be very much most malleable. It should be most malleable. That is, it can be drawn into sheets very easily, and very thin sheets it can be drawn into. And he found gold to be such metal which is most malleable and can be easily converted into thin sheets. Okay. That's why this was used. Okay. Now, if the foil of the heavy metal like platinum, the second weak part is that what do you think would be the observation of a particle scattering experiment if they carried out with heavy nucleus like platinum or light nucleus like lithium? So, if we had been platinum, heavy nucleus, heavy metal like platinum, then what would happen? That would show the same scattering experiment properties. Observations could be same as it was found in gold, because this metal will have the same type of characteristics like that of the gold. The platinum has the same type of characteristics, almost same like that of the gold. Heavy nucleus will have the same characteristics like that of the gold nucleus, and that's why it will show the same observation. But in case if it was taken light metal like lithium, where this nucleus is very light, then what would do? The alpha particles will move the nucleus away, and it will pass through it without deflecting back. Okay, so he found what? That alpha particles, some of them they moved straight without deflecting, some deflected back, and some they there's some deflected, scattered, some they reflected back totally, and some they reflected towards the sideways. So, but in this if the light nucleus was used, then what would happen? That it will move the nucleus to one side, and most of the alpha particles will deflect. I mean, it will just pass through without deflecting. Like that, it can happen. It may happen. Not sure, but it may happen. That's why he told it should be a heavy metal, heavy nuclei should be there. Then, on the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? On the basis of Rutherford's model, protons are positively charged particles and they are present in the nucleus of an atom. Then, which part of an atom was discovered by Rutherford? Rutherford discovered the nucleus part of the atom in the alpha particle scattering experiment. In this experiment, he discovered nucleus. Then, how was it shown that atoms has empty space? Rutherford performed an experiment by allowing a stream of alpha particles pass through the metal foil without deviating from their path. This showed that an atom contains a large empty space, which is known as nuclear space. So, without deviating from its path, like it moves straight, how can this be shown? He found these alpha particles pass through. These alpha particles are allowed to pass through the metal foil. Then it had passed through. Okay. Through this empty space without deflecting, and that's why he shown that atom has empty space. State one major drawback of Rutherford's model. One major drawback of Rutherford's model was the comparison of electrons with the planets in the solar system. He compared electrons with the planets of the solar system. So when an electron moved around the nucleus, when it moved around the nucleus, like the planets which moved around the sun, according to him, continuously, then it should radiate some energy and lose that energy. It should radiate energy and lose that energy, and this should result in gradual pulling of the electrons as it is losing energy, as it is radiating its energy. So it should be, the nucleus should be, the electron should be pulled towards the center of the atom, that is towards the nucleus. And that would help, that would end up in the colliding of the electron with the nucleus. And that would make the atom total collapse. So this did not happen. So this was the drawback of Rutherford's model. But we know that atoms are structurally stable. It does not collapse like that. So this is a fault of the Rutherford's model. Then in the figure given below, see, this is the figure. This is center portion, which is named as X. Then another circle is there, which is A, the B, the C. So name the shells which are denoted by A, B, and C. Which shell has the least energy? Name X and state the charge on it. The above sketch is of dash model of an atom. So A is for K shell. Okay. A, the label 1. First A is for K shell or first shell. B is L shell or second shell. C is N shell or third shell. And shell K has the minimum amount of energy. Least energy is K shell. This is the first cell, has the minimum amount of energy. And X is the nucleus, and it is positively charged because it's having the proton. And the above sketch is of Bohr model of an atom. Okay. Now get the postulates of Bohr atomic model. The postulates of Bohr atomic model of an atom is, first is, in an atom, negatively charged electrons revolve around the positively charged nucleus in a definite circular path called orbits or cells. Okay, each orbit or shell has a fixed energy, and their circular orbits are known as orbital shells. The energy levels are represented by integers, that is n is equal to 1, 2, 3, like that, continuous. Then known as quantum numbers. These are known as quantum numbers, and this range of quantum numbers starts from the nucleus site with n is equal to 1, having the lowest energy level, and it is said to be the ground state. The electrons is an atom moved from a lower energy level to a higher energy level. by gaining the required energy, and an electron moves from a higher energy level to lower energy level by losing energy. So what are the postulates? First postulate is, if an atom, in an atom, there is a central part which is known as the nucleus, and the around the nucleus there are negatively charged particles which are moving in a definite path, in a definite circular path, and that circular path, the negatively charged particles are known as electrons, and that definite path are known as orbits or shells. Okay? Now each orbit or shell, they have a fixed energy, and these circular orbits are known as orbital shells. Okay? Now the energy levels, okay, the energies, these orbits have fixed energy. So these energy levels are represented by the integer, that is n, and that is equal to 1, 2, 3, 4, and so on. So these are known as quantum numbers, and the range of quantum numbers starts from the nucleus side. From the nucleus side, it is n is equal to 1, then 2, then 3, then 4, like that as the shell increases. Okay, and the nucleus side, the n is equal to 1, that shell will have the lowest energy level, and it is known as the ground state. Okay. Now the electrons in an atom, they move from a lower energy level to a higher energy level. Electrons move from one energy level to another. So from when it is moving from lower to higher, it will gain energy. And when it is moving from higher to lower, then it will lose energy. Here, next question is, the atom of an element is made up of 4 protons, 5 neutrons, and 4 electrons. So what are its atomic numbers and mass numbers? So atomic number will be equal to number of protons or number of electrons. Okay, we know that atomic number is either number of protons or number of electrons. So number of protons should be equal to the number of electrons, because to make a stable charge, okay, so the atom is neutral generally, so the number of protons, that is number of positive charge, is equal to the number of negative charge. So for that, number of protons should be equal to the number of electrons, and that is known as, this number of protons or the number of electrons is known as atomic number, and that is denoted by Z. So Z is equal to 4, because see, you can see from the question, there are 4 protons and 4 electrons, so the number Z is 4. Okay, the mass number is the sum of number of protons than the sum of number of neutrons. So sum of protons and neutrons make up the mass number, and mass number is denoted by capital A. So A is equal to 4 plus 5, so that will become 9. Okay, then the atomic number and the mass number of sodium are 11 and 23 respectively. What information is conveyed by this experiment? In this statement. So atomic number, that is Z, is equal to number of protons or the number of electrons. So here atomic number is 11. So that means number of protons or number of electrons is equal to 11 for sodium. And mass number is 23, that is A, that is equal to number of protons plus number of neutrons. So that becomes A is equal to 23. So we know that protons is 11. So number of neutrons will be mass number minus number of protons. That is mass number minus atomic number will give us the number of neutrons. So the number of neutrons will be 12. Okay. So next question is, write down the names of the particles represented by the following symbols and explain the meaning of the superscript and subscript numbers attached. That is P dot P11, then N01, E minus 10. So P for proton, N for neutron, and E for electron, and superscript number shows their mass number. Superscript is the above one. These are all superscript. So that is the mass number, and the lower number is there. The subscript number is the charge. That is proton is +1, neutron is 0, and electron is -1 charge. So from the symbol 2412 magnesium, state the mass number, the atomic number, and electronic configuration of magnesium. Mass number A is 24, and atomic number Z is 12. So 12 is equal to number of electrons. Okay. Then electronic configuration will be 2, 8, and 2. 2 plus 8, that is 10. 10 plus 2 is 12. So 12 atomic number, or 12 is the number of electrons. Now explain the rule according to which the electronic field is various energy levels, are filled in the various energy levels. So the maximum number of electrons that can be present in any shell or the orbit of an atom is given by the formula 2n squared, where n is the serial number of the shell. N becomes the serial number of the shell, and the formula according to which the atoms are filled, the electrons are filled in the energy levels. These are 2n squared. Therefore, K shell will be n is equal to 1. So the number of electrons will be 2 into 1 square, that's 2. N is equal to 2. Therefore, a number of electrons will be 2 into 2 square, that is 8 electrons in the second shell. Like that, it will be filled up. So I'll stop here. I'll continue with the rest of the discussion in my next video. Till then, please go through the chapter first and then to the questions. And if you feel any doubt, you require any doubt to be solved, cleared, so please do mail me at my email ID at kasturi74@gmail.com, or you can also write in my comment box. And if you are a new viewer to my channel, please to subscribe my channel and ring the notification bell. And if you have already been subscribed, then please do follow my instructions, and press the like button if you're liking the video. Share with your friends so that they can also be benefited from these videos. And please do meditate before you start your day. Okay? So thank you for joining, and have a good day.